So the particle problem is going to be one that you're going to see a lot of, right? And in this case, we're talking about a particle moving along the x-axis, and for time being between 0 and 10 seconds, its position is given by x of t equals t cubed minus 3t. So the first thing you're asked is, where did it start? And so its starting time would be 0 seconds, and if you find x of 0, we just plug 0 in. And we see its position is at 0, so at the origin. Where was it at 10 seconds? Well, that's finding x of 10. So we got to plug that in, 10 cubed minus 3 times 10. So that'd be 1,000 minus 30, or 970 units. Then getting into part C, finding the average velocity. Remember, the average velocity is finding that rate of change over this entire interval. So it's not the derivative, it's more like a slope, it's a rate of change. So we're trying to find the change in position from 0 to 10 seconds over the change in time from 0 to 10 seconds. So in this case, it started at 0. After 10 seconds, it was at 970. And then we divide by negative 10. So negative 970 over negative 10 leaves us with 97 units per second. Now when the question asks for the velocity function, this is when we're looking for the derivative. So velocity, remember, is the derivative of position. So in this case, the derivative of t to the third minus 3t, that would be 3t squared minus 3. Then when is it stopped? Well, that would be when its velocity is equal to 0. That's when it stopped. So we have to solve the equation 3t squared minus 3 is equal to 0. We can factor out the 3 and be left with t squared minus 1. Factoring that again, we'll have t plus 1, t minus 1. And so we see that it'll happen when t is at negative 1 and positive 1. However, this is only a position function for time being between 0 and 10 seconds. So we're not looking for this negative answer. It will only be stopped at the 1 second mark. So how about at the 4 second mark? Is it moving to the left or to the right? And again, we can look at velocity to figure that out just by finding the velocity at the 4 second point. So that'd be 3 times 4 squared minus 3, or 48 minus 3, which is 45 units per second. Now, there's nothing special about the 45 other than it is positive. Since that is a positive velocity, that's going to mean that the particle is moving to the right, because the right is a positive direction. Now, the last couple questions have to deal with acceleration. We know the position function, we know the velocity function, and now we're asked for the acceleration function. So we need to remember that acceleration is the derivative of velocity. Since velocity is 3t squared minus 3, the derivative of that would be 6t. So that's our acceleration function. Now if we want to know if that velocity is increasing or decreasing at 4 seconds, we actually evaluate its acceleration function at 4 seconds. So that's 6 times 4, which is 24. The units here would be units per second squared. And again, all we care about is whether or not this is a positive or negative number. Since acceleration is positive, that means velocity is increasing. If that acceleration were negative, then the velocity would be decreasing.